Perimeter of circle. Now, the first thing which comes to your mind listening to this may be 2 pi r. And you all are correct. 2 pi r is the formula to calculate perimeter or circumference of the circle with r as radius. Now, many of you might be wondering that where does this formula come from? What is its origin? Now, if you're seeking for the answer for this question, you are in the right video. So, without wasting any time, let us start deriving this formula. Now, first of all, let me consider a circle. Okay, now this is a circle with center as O and radius as R. As simple as it is. Now, what I'm going to do here is that I'm going to divide this circle into very small fragments. These fragments are very small that they are almost tending to zero. They're very small fragments. I've divided this circle all the way up to here. So this small fragment, since it is almost tending to zero, it's extremely small. I'm seeing it as dx. Okay, since it is very small, dx itself means it is tending to zero. Now let me join this. Now we know that since dx is very small, its corresponding angle will also be very small. So this angle over here is almost tending to zero. It's very small since its corresponding arc is small. So I'm calling it as d theta. Now, what I have to do, I have to add these small fragments which I have cut down to get the full circle, to get the perimeter of the circle. To do this, I'll not add it simply like this because this is not the way to deal with very small quantities. We'll use, yeah, you got that right, integration. We'll integrate dx. Now, since we are integrating it, we have to put some limit that from where to where we are integrating it. Now, since we are integrating it from 0 degree angle from here all the way to 360-degree angle up to here. So its limit will be 0 degree to 360 degree or 0 radian to 2 pi radian. But our integrating variable is x. It is not an angle. So we have to convert this into theta. So how do we convert it? It's a challenging task, but not when you are in my video. Now in triangle we know that angle is equal to its corresponding arc upon radius. Now putting the values here we get d theta equal arc which is dx upon radius which is r. Now here we get dx equal r d theta, as simple as it looks. Now let me substitute this in our original expression. We'll get r d theta. Now we know that integration have some limits, and now we also know the limits of this integrating variable as from 0 to 2 pi radian. Now since r is a constant, we'll get this expression with its limit going from 0 to 2 pi. How to calculate this? 2 pi minus 0, which is upper limit minus lower limit. I'm sure you might have learned. Ladies and gentlemen, perimeter of the circle.